Noah for crying out loud places a 5 Coulomb charge how far from a 3 Coulomb charge to make the force between them exactly 4 newtons. Now 4 newtons is a pound, so you would feel this force, right? So the question is, what is the separation, right? So the electrical force is KQQ over R squared, right? So therefore, R squared is KQQ over F, right? And so therefore, R is equal to the square root of KQQ over F, right? So R is equal to the square root of 8.99 times 10 to the 9th. That's a huge number, right? And then we're multiplying by 5 and by 3 and dividing by the force, which is 4. As you might imagine, this is a tremendously large distance. 8.99 E9 times 5 times 3 divided by 4. And then I'm going to square root that. And I get a big number, 183,609.64 approximately meters, right? Let's see, what is that? 183,609. It is 183. It's 1.84 times 10 to the 1, 2, 3, 4, 5 to the 5th meters, or basically 184 kilometers, which I think is like between here and Lincoln City or something like that, some crazy thing, right? So this is why, of course, a Coulomb is 5 coulombs is a tremendous charge, right? And I keep saying tremendous, that's terrible. It's a very big charge, okay? It's tremendously huge. Okay, but anyway, so this is, it's not likely that we would get these two charges in the same laboratory, right? Much less, in Portland or Tuolin or something like that. Anyway.